technology can be a blessing and a curse. And the curse is that we can become so reliant on it, and we don't even necessarily learn some of the basics to know how the plant sounds when it's running correctly and how it sounds when there's something wrong.
Process Safety with Trish and Tracy is a production of Chemical Processing. Chemical Processing focuses on serving engineers, designing, and operating plants in the chemical industry.
Welcome to Process Safety with Trish and Tracy, the podcast that aims to share insights from past incidents to help avoid future events. I'm Tracy Purdom, Executive Digital Editor with Chemical Processing, and as always, I'm joined by Trish Kieran, the Director of the iChemie Safety Center. This episode is sponsored by Pepperell & Fuchs. Mobile devices are critical for communication and information gathering in processing plants. However, using the technology in hazardous areas presents challenges. Rely on the explosion protection experts to protect your plant and equipment. Pepperell & Fuchs' e-com mobility portfolio, including smartphones, tablets, scanners, and more, is designed to meet the environmental requirements of today's chemical processing plants. And Trish, actually, this fits in pretty well with our topic today, which is new technology and safety. And had me thinking about all the movies when I was growing up that freaked me out about new technology and thinking technology would take over the world. 2001: A Space Odyssey left me more in wonder than fear, but The Terminator and The Matrix, nope, that was a little too much for me. So given the rapid pace of which technology advances in the movies and in real life, chemical facilities need to understand the risks, rewards, and best uses. So I'm going to toss that huge, broad question out to you. What are the risks, rewards, and best uses of efficient machines, i.e. automation and robotics?
Wow, so that is a massive, massive question to try and address. I'll do my best. I think I just want to throw in my movie reference here, and I'm just disappointed we still don't have the hoverboards from Back to the Future. But, you know,
for sure.
Maybe one day we will. Or at least not at commercial level anyway. So, yeah, the risks, rewards, and best uses. There are risks in everything we do, and we need to understand and accept that there are just risks in everything we do in life. Nothing is risk-free. It's all around how we manage that risk. And we also need to understand that there's also an upside to risk. There's the risk of something going wrong, but there's also the opportunity for something to go right and go well. So it is a two-sided coin, this risk discussion. And that's where the rewards come into it. That's why we want to think about the rewards of these different applications. Now, in terms of where their best uses might be and where we might be applying them, obviously, if we have activities that pose a hazard to the human that has to actually do the activity, then if we can automate that in some way, if we can put some robotics in there to do the task, that is going to be a better outcome than potentially exposing the worker to some form of hazard. So we can actually use these sort of devices to remove the worker from the hazardous situation and allow them to work more remotely from it, allow them to be at a distance, to do some activities in a much safer environment. As an example, at large scale, there's a lot of mining that goes on now that is fully automated mining. So these are haul pack trucks, which are the biggest trucks on the planet. These are massive, massive trucks that are being driven from thousands of miles away. They are being driven remotely from someone sitting in a control room, in the safety of a control room, actually moving this massive truck around a mine site. They obviously can't be in a vehicle accident and injure the driver when the driver is sitting at a control panel thousands of miles away. Remotely driven trains are also being used in the mines as well now to transport the ore to various different locations without the need for a driver being there potentially in hazard's way. They can actually be really, really useful and give us great rewards in that. The thing is, though, we're not at a stage of artificial intelligence that is intelligent enough for us to just let it go and do its own thing. So humans are still involved. We're still part of the equation, and I think we will be for a very, very long time to come. And I think that's an important part to remember as well. Automation is not about just getting rid of the human. That is not what we're trying to do. What we're trying to do is create safe and efficient operations that don't put the human at risk. And I think if we can approach it in that way, because the human still designs it, builds it, maintains it, and actually operates it just from a distance in some way. We're still intricately involved in that process.
You bring up a lot of great points there, but I'm wondering now about like new software solutions. Is there anything that needs to be considered on that side of the coin?
Absolutely, especially when we are talking about robotics or automation. We need to very thoroughly test the software applications so we know what is going to occur, particularly if there's a bug in the software somewhere or if a glitch occurs and the automation behaves in a way that we didn't expect it to. Incredibly detailed factory acceptance testing, which is something that we do on all sorts of other electronic applications we put into facilities. You know, we factory acceptance test all the components of a distributed control system before we install it. We need to factory acceptance test in this instance as well. We need to be going through thorough testing protocols and putting it through its paces to make sure that if something unforeseen happens, we know what the response is going to be so we can manage it or intervene if we need to. Because we've got to be able to deal with those unintended consequences. That's where I think we're really going to see some issues arise if we don't get a good handle on doing that. So getting the testing right, getting the testing protocols right, you know, having the people in your organization test this stuff to literally see if they can break it. That's what you're trying to do. You're trying to test it to see if you can find where it's going to malfunction in some way so you can work your way through that and prevent that malfunction in the field.
Obviously, communication has come a long way, made a lot easier with wearables and smartphones on the factory floor, but are there safety issues to consider there?
Look, definitely, and in fact your introduction spoke about it today. When we are working in hazardous areas, we need adequately designed hazardous area equipment. So we need all of our electronic devices that are in the field to be designed in such a way that they are intrinsically safe and therefore they cannot be the ignition source for a fire or an incident to occur. So we've got to take into account the hazardous area classification and make sure we work with that. We need to understand precisely what we have to have and ensure that we, one, have the right equipment, but two, also operate it and maintain it correctly. Because if we don't operate and maintain intrinsically safe equipment correctly, it can lose our intrinsic safety in it. So we need to make sure we do that as well. There's a couple of other parts to think about, though, that we don't always really focus on. Awareness. Our situational awareness changes when we actually are focused on our mobile phone or our tablet or doing something else. That's why we're not meant to drive and use our phone at the same time. That's why it's illegal in most places to drive and use your phone. The distraction level can be quite significant. We need to make sure that people remain with enough situational awareness so that they can continue to notice what's going on and respond as necessary. So that awareness part's very, very important. That awareness part also comes into the situation if we're using augmented reality. Now, I think there's a really interesting application for augmented reality in the industrial field. I think it can be a game changer in some of the things that we do. But, again, are we blinding people to what's around them, to their situational awareness, when we put a pair of glasses on them that start to show them all sorts of things in the lens? And so they look at a pump and they can see all sorts of different factors around that pump. I think it can be, as I said, a game changer if we can get this right in how it works with the human brain. But we also need to be very careful we're not losing that situational awareness at the same time. Obviously, from a training perspective, virtual reality can be quite handy as well. Virtual reality can be really useful in helping someone go through what to do in an emergency, for example. I think for me the challenge with virtual reality is how we get it so seamless that we don't get people getting motion sickness from it. I think some people can use VR for really long periods of time without a problem at all. I'm one of these people that needs to just take the headset off and sit and rest for a moment before I can put it back on again. So, you know, we need to get a little bit better on some of the smoothing out the glitches in some of these things. But I think there's some amazing wearables that are out there. Even things like making sure that, you know, if we are monitoring someone's exertion rates in a hot environment to make sure that they're not overstressing. So we can measure their heart rate remotely and measure their O2 saturation as well. These are all really important things to get the safest environment we can for our workforce.
What about like the cyber issues with these types of technologies on the plant floor? Do we have to worry about that?
Absolutely. Cyber is one of the biggest issues we do need to worry about. So thank you for bringing that one up. Especially at the moment, we are at a situation in the world where significant cyber risk is a massive challenge for us. There are not only nefarious people that just want to do it for fun or for ransom, but there are also state actors involved for other reasons. We need to be very, very careful about making sure we have the right defense in depth to manage our systems from a cyber hacking perspective. We've seen instances where cyber hacking has occurred on production plants and facilities. Now, we've actually seen instances where they have been able to make the plant do things that the plant operators couldn't prevent. Now, that's quite terrifying if you think about whether that could have been a nuclear power plant, for example. There have been attacks on nuclear power plants, or whether it's just other sort of instances. One of the first ones that occurred was a plant was sent haywire that pumped raw sewage back up through all of the systems connected to it in a particular suburb. And, one of them was a 5-star hotel was, flooding with sewage because someone had got in there and deliberately reversed the flow on everything. So we need to be very, very careful about how we deal with cyber. So we also have wonderful things where we might have Wi-Fi repeaters in the plant so that, the contractor can read the data that's going on through their particular piece of equipment. How secure is that Wi-Fi? Can that be hacked? In fact, that's how that sewage plant was hacked. It was hacked through the Wi-Fi system. So we need to make sure that we've got the right defences in place so that we do have the security of our technology and we can maintain it. We also need to assume, though, sadly, that it's not if you'll be hacked, it's when you'll be hacked, and you will be hacked. So you need to make sure that you can shut it down and control what's going on when it happens, because it will happen. It's not, unfortunately, we can't just say, well, we'll make our system so secure no one will be able to get in. I'll guarantee you someone can get in. Someone right now is trying to get into your systems. That is just a fact of life today. So you need to be able to also shut down and adequately recover after the event.
That brings up the point of, do we rely too much on technology? You brought up on numerous occasions that we need to be prepared in case of systems are down due to NATEC events, and as you pointed out, the nefarious reasons. Can you talk about the steps and best practices in terms of safety and maybe relying too much on technology?
Yeah, so it's a fascinating area because, technology can be a blessing and a curse. And the curse is that we can become so reliant on it and we sit back and we don't even necessarily learn now some of the basics and learn to know how the plant sounds, for example, when it's running correctly, and how it sounds when there's something wrong, because we sit in our control room and we operate it from there. We need to make sure that we go back and provide some of that adequate site familiarization for people so that they do know how the plant sounds, how it feels, how it smells. These are all things that occur in a plant. And, I've worked in plants where you'd walk past and you'd go, that pump's not running right today. There's something wrong with it. And you'd go back in and sure enough, you would discover that there was a vibration in the pump or something like that. So as humans, we have the ability to detect these things when something changes. That means we actually do need to have interaction to notice when something changes and also have that great sense of awareness that we're refreshing it on a regular basis so we can see when the change happens. So I think we need to ensure in our training and development programs that we actually still do plant awareness, and we make sure that as people graduate up to working in the control room at that point, that they've had some really good hands-on plant operating experience, that they know what it's like to walk through the plant and to hear the sounds and to see the sights and the smells and feel the temperature changes at times as well. So I think that's a really important thing to try and make sure that we maintain that level of awareness. So, for example, if you want to become a pilot, you still have to learn all the basics of flight avionics. You have to learn all about how flight occurs, all the physics of it. You then have to learn how to navigate without any instruments. You have to learn how to fly without instruments. You have to learn all these things before you're allowed to use all those wonderful tools that they have. And you'll often hear pilots talk about, in the event of an emergency, there's only 3 things that they do, and they do them in this order. they aviate, they navigate, they communicate. So first of all, they keep the plane in the air, they aviate, they fly it. Then, once they've got it flying, then they can start to think about how they navigate to where they're going and what they're going to do. And once they know what's going on, then is the time to communicate. So, those things can happen very quickly, but it's about, first of all, you've got to keep the thing in the air. You've got to keep it going in the right direction. And then you've got to tell someone that something's going on. And we need to, take that approach. What do we need to do to keep the plant in a situation when we've lost the control systems? We should be actually working towards a safe shutdown. So what do we do to safely shut down? What do we have to do in that process? What do we need to do to make sure we're still going in the right direction for all that to happen? And then who do we call for help? So, focusing on some of those really basic steps is quite important. Fundamentally, understanding the process we're operating, understanding how it works together, what the process flow diagram looks like, and how it works as a system is important, so that we can know what to do if one of the systems plays up somehow.
Great advice there. My last question is always anything that you'd like to add to the topic that we didn't touch on.
I think I'd probably just circle back to that awareness and using wearables in zones. And it'll sound quite amusing as a reference, but if you think about when the world went crazy over playing Pokemon and the number of instances where people walked out in front of traffic or they didn't realize what was going on around them because they were too busy trying to catch the Pokemon on their phone that they could see. So they weren't watching the peripheral vision. They weren't situationally aware. So whilst it was a great fun game that got kids out and about playing outside, which was fantastic, we also needed to be aware about the situation awareness stuff for it. So I think really from my perspective, making sure that people focus on understanding the limitations of the equipment and how they're going to deal with that equipment, I think is a really important thing. So think about your Pokemon when you're out there with your augmented reality and don't go running in the path of something dangerous.
Well, as always, Trish, you help to focus us, and I appreciate that. I'm going to go back and watch Back to the Future and look at those hoverboards. We kind of came close to the hoverboards, not in the same realm as Michael J. Fox flying around, but I do appreciate the time you put into today's topic for us. Unfortunate events happen all over the world, and we will be here to discuss and learn from them. Subscribe to this free podcast so you can stay on top of best practices. On behalf of Trish and our sponsor, Pepperell & Fuchs, I'm Tracy, and this is Process Safety with Trish and Tracy.
Stay safe.